we're going to do work on logarithms for standard 9th. We have a few questions based on the things whatever we have learned, and let us see this question. In question number 1 I have, if x square plus y square is equal to 23xy, then prove log x plus y upon 5 is equal to 1 upon 2 log x plus log y. I am finding it more attractive to start from here and go to there. So I'm starting from this side. Like it is more complicated, you start with the more complicated side. Log x plus y upon 5 is equal to half log x plus log y. Log x plus log y means log x into y. Log a plus log b is log a into b. So it will become half log xy, and this is log x plus y upon 5. This power half can go up. Log x plus y upon 5 will become log xy to the power 1 upon 2. It will become to the power 1 upon 2. Now it is a single logarithm this side. It is also a single logarithm this side. We told you when left hand side and right hand side have single logarithm, then we can remove the logs from there. Like it is x plus y upon 5 is equal to x y to the power half. It is xy to the power half, or x plus y will be equal to 5 into xy to the power half. That is under root. Now I have to remove this under root. We will square both the sides. X plus y whole square will become 25xy. When we square 5, I get 25. xy to the power half. When we square, we get xy. It is x square plus y square plus 2xy is equal to 25xy, or x square plus y square will be equal to 23xy. It will become 23xy. X square plus y square is equal to 23xy. So we started from the more complicated side, because from this side it is looking little difficult to you. If I take log a square plus b square, what am I going to do? How am I going to do? But this is a more complicated side. Start from this side, achieve that side is one and the same thing. Now let us see the second question, part A. In part A, I have 1 upon log 42 to the base 2 plus 1 upon log 42 to the base 3 plus 1 upon log 42 to the base 7 is equal to 1. What I am going to do is that I am going to change their bases, interchange the bases. I want to make every base 42 because 42 is given here. So I can make every number's base to be 42 by just taking them up. If they are in the denominator, take them to numerator. It will become what? Log 2 to the base 42 will become. It will interchange. The bases will interchange. Plus log 3 to the base 42 plus log 7 to the base 42. So everywhere base is 42. Because if bases become same, then you can apply log a plus log b plus log c. So it will become what? Log 2 into 3 into 7 to the base 42. Now 2 3s are 6, 6 7s are 42. Log 42 to the base 42. When a number has a same base, log of a number to its own base, same base, is always going to be equal to 1, because only 42 risen to power 1 can give you 42. I cannot find any other number here which I can raise this number to get 42 except 1. So 42 to the base 42 is 1. So we generally say log a to the base a is always equal to 1. The number to its own base is always going to be equal to 1. That is why log 10 to the base 10 is 1. Log 1 to the base 1 is what? 1 also. So we have got the answer. We have converted the bases. How do you convert the base? If you want to interchange the base with this, then what you do is you just take them to the, if they are in the denominator, take them to numerator. If they are in numerator, take them to denominator. Now let us see this second part of this, B part of this. In the B part, I have 1 upon log 36 to the base 8. This will be also the same way. Plus 1 upon log 36 to the base 9. Plus 1 upon log 36 to the base 18 is equal to 2. So what am I going to do is I am going to again take them into numerator and change the base. So interchange these two. Log 8 to the base 36 plus log 9 to the base 36 plus log 18 to the base 36. Since your bases have become same, you can log a plus log b plus log c can be written as log a into b into c upon, to the base 36. It is how much? Log, what will be left? Let us find out 9 fours are 36. 2 to the power 3, 3 to the power 2, and 2 into 3 to the power 2. 2 to the power 3 is 8, 3 to the power 2 is 9, and 2 into 9 is 18. What I'll do is I'll try and bring here 36. I'll bring it here 36. I could have done it also simply by writing 36 into 36. Why? If you see, just see it. 4 into 2 into 9 into 18. 9 into 4 is 36, 18 to the 36. So it will become log 36 to the power 2. And base is how much? 36. Instead of multiplying them and then finding out the square root of that number, it is easier to think it this way. I wrote 8 as 4 into 2, 9, and 18 I left it as is. 18 2s are 36, 9 4s are 36. That means it is 36 into 36. So I wrote 36 to the power 2. It will become 2 log 36 to the base 36. So 2 into 1 is 2. That is what the answer is. Now let us see question number 3. Question number 3 I have, first part is 1 upon log ABC to the base A plus 1 upon log ABC to the base B plus log 1 upon log ABC to the base C is equal to 1. Again, I am going to change the base to the same. I'll take the number of logarithm from denominator to numerator. It will become log A upon A to the base ABC. It will become log B to the base ABC. It will become log C to the base ABC. Bases are same, ABC, ABC, ABC. So it will become what? Log A into B into C to the base ABC. So it will come what? Log ABC to the base ABC. The number to its own base, log of a number to its own base is always 1, and we wanted to prove it equal to 1. These questions are almost same. They are exactly the same question. Actually, we are using the principle of changing of the base of the logarithm. The second part of this question is log A to the base B into log B to the base C into log C to the base D is equal to log A to the base D. So what we are doing is, let us change the base. Let us first of all, we can write it as log A upon log B. Suppose I change to the base 10, to the base 10. So log B, or let it be any base. Let it be any base. I can write it as log B upon log C, or I can write log C upon log D, to any base. Now log A is not cancelling, log B will cancel, log C will cancel. It will be left log A upon log D. That means log A to the base D. We had to prove this only. We had to prove this. In most of the questions which we have dealt with, we are talking of the change of the base in case of logarithms. For example, in this question number 1, it is given that log x to the base 3 plus log x to the base 9 plus log x to the base 81 is equal to 7 upon 4. I have to prove it to be equal to 7 upon 4. So what am I going to do? Left hand side, if I take log x upon log 3, I can write, plus log x upon log 9, I can write, plus log x upon log 81, I can write. In all these things, you can see log x is common. Log x is common. 1 upon log 3 plus 1 upon log 3 to the power 2 plus 1 upon log 3 to the power 4. So it will become what? Log x, and this is 1 upon log 3 plus 1 upon 2 log 3 plus 1 upon 4 log 3. So if I take log 3 also outside, log x upon log 3, and it is what? 1 upon 1 plus 1 upon 2 plus 1 upon 4. And I add this log x upon log 3, and we add this. LCM is 4. So 4 plus 2 plus 1, it is 7 upon 4. Log x upon log 3, and this is 7 upon 4. So what will happen? Okay, 7 upon 4 log x to the base 3 I can write. He wants you to calculate x. He wants you to calculate x. So it is not equal to 7 upon 4. You have to find value of x. So it is equal to 7 upon 4. Is equal to 7 upon 4. So 7 upon 4 log x to the base 3 is equal to 7 upon 4 will cancel from both the sides. Log x to the base 3 is equal to 1, or 3 to the power 1 will be equal to x. So the value of x is 3. You don't have to prove it equal to 7 upon 4. You had to solve for x. You have to solve for x. So what we did was log x was common everywhere. Log 3 we converted, log 9, log 3, log 9, and log 81 we converted in terms of log 3. And then we took out common, log x to the base 3 it has become. And 7 upon 4 came, 7 upon 4, 7 upon 4 cancel from both the side. Log x to the base 3 is equal to 1. That means 3 to the power 1 is x. If I change it to index form, and x will get to be 3. 3 to the power 1 is 3. The same way, let us solve the second part of this question, where we have to get the value of x. It is log x to the base 2 plus log x to the base 8 plus log x to the base 32 is equal to 23 upon 15. 23 upon 15. Again we do the same thing. We'll write it as log x upon log 2 plus log x upon log 8 plus log x upon log 32 is equal to 23 upon 15. We take log x common from this. Log x will come out to be common. It will be 1 upon log 2 plus log 8 can be written as 2 to the power 3. So it will be 1 upon 3 log 2 plus 1 upon 32, 2 to the 4 to the 8 to the 16 to 2 to the power 5. So 5 log 2 is equal to 23 upon 15. So log x, we can take out log 2 here. It will become 1 plus 1 upon 3 plus 1 upon 5. Or you add them, one and the same thing, you will get how much? Is equal to 23 upon 15. So it will become log x upon log 2, and I will get 15, and actually you will get 23 only. Is equal to 23 upon 15. So these two will cancel, and you will be getting log x to the base 2 is equal to 1, or 2 to the power 1 is equal to x, or x is equal to 2. That finishes your chapter of logarithms. Practice that and we'll see further. Thank you.